Did 3i Atlas just change course? Or are scientists misreading a signal that shouldn't exist in the first place? That's the question erupting across astronomy circles after a new wave of orbital data appeared to show a deviation too subtle to ignore, yet too significant to brush off as noise. And while no one is claiming aliens, no one is ruling out exotic physics either. Something strange is happening around the interstellar visitor.
That strange interstellar visitor turning heads among the scientific community. Big questions still remain about 3i Atlas. Now, a lawmaker is pressing NASA for new images of the space phenomenon, and could it also have a traveling companion?
And the latest observations only deepen the mystery rather than resolve it. When 3i/Atlas first entered our solar neighborhood, astronomers treated it as the third confirmed interstellar object after Oumuamua and Borisov, another cosmic traveler from outside the sun's gravitational well, likely benign, likely explainable. And at first, it behaved exactly as expected: a hyperbolic path, high velocity, low reflectivity, and a composition profile that didn't neatly match comets from our system. But in the past weeks, subsequent monitoring from multiple observatories began picking up a pattern that wasn't predicted in the models. The object's position wasn't off by much, just fractions of arcseconds. But when you're dealing with interstellar bodies, even a microscopic deviation can imply massive forces at play. Scientists initially chalked up the anomaly to simple measurement error. Long-distance tracking is notoriously difficult, especially with an object this faint and with such a narrow observable window. A miscalibration here, a temperature glitch there, maybe even a software smoothing artifact. These were the easy explanations, the comfortable ones. But then a second dataset arrived, then a third.
And the amount of boost to its velocity was equivalent to a jet carrying 5 billion tons of matter that would give it a recoil.
Then another facility confirmed it independently. Suddenly, the idea that it was just an error began to fade. If multiple instruments, in different hemispheres, under different atmospheric conditions, were seeing a similar shift, the likelihood of coincidence shrank fast. So what exactly changed? Astronomers are careful in their language, but the basic idea is that the trajectory appears to have deviated slightly from the expected gravitational path.
And we have an exciting hearing today on NASA's efforts to save the world.
Not in a dramatic Hollywood-style turn, but in a soft, gradual curvature that raises more questions than it answers. A comet shedding mass can drift. Radiation pressure can cause subtle pushes. Outgassing can alter momentum. These are normal processes. The problem is that 3i/Atlas hasn't shown the usual signatures to support any of these explanations. If outgassing were driving it, we'd expect a visible coma or at least thermal emissions. If radiation pressure were doing the work, its mass-to-area ratio would have to be unusually low, far lower than typical for natural objects. If internal fragmentation were occurring, telescopes would catch debris or changes in brightness. None of that is happening.
As of this morning, some observers noticed that it has a set of jets around it, more than 7. Some headed towards the sun, some away from the sun.
One camp believes the deviation is real, but still natural. They point to the possibility of cryovolcanic pockets that only vent under specific conditions, or extremely low-density material similar to Oumuamua's suspected pancake-like shape, reacting differently to sunlight. Another theory suggests it could be coated in extremely dark material that masks emissions, allowing subtle forces to act without being easily detected. This group essentially argues, yes, it's weird, but nature can be weird without needing extraordinary conclusions. The other camp is more cautious, borderline uneasy. They note that 3 interstellar objects and 2 of them behaving in unexpected ways is statistically questionable. Borisov behaved like a normal comet, but Oumuamua's acceleration and strange reflectance weren't fully resolved, and now 3i/Atlas seems to be echoing that same pattern, movement without a known mechanism. Not identical, but uncomfortably similar. The concern isn't aliens in the sci-fi sense. It's that something about interstellar material doesn't match our current understanding. This opens the door to exotic explanations, non-gravitational forces we haven't modeled, unknown structural compositions, or even interactions with interstellar magnetic flux. Some astronomers have pointed out the timing coincidence that adds another layer of intrigue. The shift appeared just as 3I/Atlas entered a region where the solar wind pattern changes significantly. It's the kind of area where charged particles behave differently, where magnetic fields twist and reconnect, where small objects could in theory respond in ways we haven't fully studied. But the counterargument is simple. Nothing else drifting through this region, comets, asteroids, debris, behaves like this. So unless 3I/Atlas has a unique property, the environment alone can't explain it. There is also the possibility of micrometeorite impacts. Even a tiny collision at interstellar speeds could alter direction. But again, that usually leaves optical signatures or brightness changes, neither of which have been detected so far. This makes the hypothesis unlikely unless the impact was extraordinarily small and perfectly aligned to produce a measurable but subtle net shift. The strangest part isn't the deviation itself, it's what the models predict next. According to the updated simulations, if the current data is accurate, the object may continue drifting in a way that slowly increases over time instead of tapering off. That behavior is inconsistent with a one-time event like an impact or a gas jet. It looks more like a continuous external influence. And continuous forces usually mean radiation pressure or outgassing, both of which should show signs. So we end up in a loop. The force appears steady, but there is no evidence of the mechanism. A few independent researchers have brought up a phenomenon called Yarkovsky drift, where thermal photons can push an object over long time scales. But Yarkovsky effects are extremely slow and require rotation combined with significant surface heating. For a fast-moving, cold interstellar visitor with limited solar exposure, the force would be minuscule, nowhere near the amount required to produce the detected curvature. This leads to the possibility nobody wants to vocalize too loudly, that the anomaly may not be environmental or internal, but structural. Some believe 3I/Atlas could be composed of ultra-porous material, something almost aerogel-like, which reacts differently to sunlight. Others propose it might be metallic in certain patches, giving asymmetric reflectivity that causes small but consistent torque. These explanations aren't impossible, but they push the boundaries of what we've seen in natural planetary bodies so far. What's really driving the speculation is how similar the conversation sounds to the one surrounding Oumuamua. Back then, astronomers debated whether the acceleration could be explained naturally or whether it indicated something engineered or exotic. Eventually, most leaned toward natural explanations, even if the exact mechanism remained unresolved. But now, with 3I/Atlas behaving oddly too, the statistical comfort of coincidence is eroding. 2 anomalies out of 3 interstellar visitors is enough to trigger a quiet but serious reevaluation of assumptions. The public fascination, of course, exploded instantly. Every time an interstellar object does something unexpected, it fuels speculation about extraterrestrial probes or artificial origins. Scientists dismiss these ideas as premature, but they don't dismiss the questions entirely. Because even if the object is natural, understanding its behavior can reveal secrets about the material, forces, and physics of deep interstellar space, places we cannot yet explore directly. Behind closed doors, several research groups are pushing for accelerated observation schedules. New instruments, especially those capable of infrared and spectral analysis, are being redirected to capture every last bit of data before 3I/Atlas becomes too dim to track. Once it exits the observational window, we may lose the chance to understand what caused the deviation. The pattern we see now could be the only clue we get for decades. And that's where the real pressure sits. The clock is ticking. Interstellar objects don't stay in view for long, and every hour counts. There's a growing sense that if astronomers can't lock down the explanation soon, 3I/Atlas will leave behind more questions than answers, just like Oumuamua. It's a repeating pattern that no one is comfortable with. What's next is a race between time, technology, and interpretation. If additional data confirms the trajectory shift with higher precision, scientists will have to rework the models of interstellar object behavior. If the deviation disappears as new measurements come in, the anomaly may collapse into the category of overinterpreted noise. And if the pattern strengthens, if the curve continues to build, The entire conversation around non-gravitational forces in interstellar objects will change overnight. For now, the story isn't that 3I/Atlas changed course dramatically. The story is that it changed just enough to matter. Just enough to raise eyebrows. Just enough to push astronomers back into the uncomfortable space between known physics and emerging mystery. Just enough to remind us how little we truly understand about what travels between the stars. And as the next round of data comes in, the world will be watching to see whether 3I/Atlas reveals a new chapter in interstellar science, or adds another unsolved cosmic question to the growing list.